Hello, everyone, and welcome to today's webinar, The Impact of BED Kiestra Total Lab Automation at Houston Methodist Hospital, Expanding Microbiology Lab Capacity and Reducing Turnaround Times. I am Marie Stone of Labroots, and I'll be your moderator for today's event. Today's educational web seminar is presented by Labroots and brought to you by BD. To learn more, visit bd.com. We encourage you to participate today by submitting any questions you may have during the presentation. To do so, simply type them into the Ask a Question box and click Send. We'll answer as many questions as we have time for at the end of the presentation. You may also submit any technical issues here as well if you have trouble seeing or hearing the presentation. This webinar is educational and thus offers free continuing education credits. Please click on the continuing education window at the bottom of your screen to obtain your credits. I'd like to now welcome our speakers. Dr. Scott Wesley Long. Dr. Long received his MD degree in 2007 from the University of Texas Medical Branch, UTMB, in Galveston, Texas, where he also earned a PhD in experimental pathology. After finishing his doctoral studies, Dr. Long completed a clinical pathology residency at Houston Methodist. Dr. Long joined Houston Methodist Hospital in 2011 and received his faculty appointment at the Weill Cornell Medical College in 2012. He is subspecialty boarded in both medical microbiology from the ABMM and clinical informatics from the American Board of Pathology. He is currently an associate professor of pathology and genomic medicine and medical director of microbiology at Houston Methodist Hospital. We are also joined by Ms. Patricia Chernock. Ms. Chernock received her Bachelor of Science in Microbiology from Texas A&M University. Since joining Houston Methodist Hospital in 1981, Ms. Chernock has taken on increasing responsibilities, including multiple teaching and supervisor positions. She is the current microbiology lab manager at Houston Methodist. Dr. Long and Ms. Chernock, you may now begin your presentation.
All right, thank you very much, and thanks everybody for joining us today. Look forward to talking to you about our experience with the Kiestra and what some of the benefits have been for us here in the laboratory at Houston Methodist. So just first, in terms of disclosures, I don't have any relevant conflicts of interest to disclose at this point. And I think for most people who are interested in lab automation systems like the BD Kiestra, one of the first questions you are confronted with is making a business case for it to administration, because these systems are not obviously inexpensive. They are large capital acquisitions, and as such require leadership support and buy-in and significant capital resources to acquire. And hospitals have limited resources. I think we all can appreciate that in the modern age, and that to make the business case, you're going to have to generally generate some sort of justification or ROI for your leadership to justify the allocation of the capital resources you need to acquire an automation system. And so I think the question that confronts any of us, certainly confronted us here at Houston Methodist back years ago, and we started this process, and will confront anyone who goes to acquire one of these systems, is how can you justify the acquisition of a large automation line or upgrading an automation line if you have one already that you've outgrown. And so one of the common ways that people will suggest that you try to justify acquisitions like an automation line will be in terms of FTEs and the theoretical reduction in FTEs. And that's usually what maybe your bench technologists are worried about, is are people going to get laid off? That sort of a question. And so we sort of confronted that head on in the very beginning by essentially refusing to accept the idea that we were going to reduce FTEs by acquiring an automation system. It may seem a little counterintuitive at first, but what we realized in the reality of our lab and our labor market was that essentially we were almost always in a constant state of hiring as the lab expanded, and to the point now where we're somewhere in the neighborhood of 60 to 70 FTEs, and it's just sort of, we continue to add beds, we continue to add locations, our volumes continue to increase, and so we have enough employees that almost at any point we're fully staffed. Within a week or so, someone for one reason or other is leaving because they're moving, or a spouse's job has moved, or other reasons. So we're sort of constantly hiring. And rather than focusing on a reduction in FTEs, we put forth to our leadership that we were going to be able to use our existing FTEs more efficiently and bring on more new testing and sort of absorb more of this constant year-over-year increase in volume without additional FTEs by acquiring the system. So it's a little bit of a different approach to trying to do the justification, and it also requires a little bit of finesse, because sometimes cost avoidance ROIs are harder to get buy-in on than a more direct sort of a cost reduction ROI, like eliminating positions or things of that nature. But we thought, based upon the labor market and for technologists, and I think this is pretty much universal across the nation, that we need to be able to maximize the staffing that we did have by acquiring this automation system to cope with sort of our growing and continuously growing volumes. We also argued that the automation lab would benefit patient care. And so we had a strong belief and hypothesis that automation would decrease turnaround times and lead to patient care benefits. We know from prior work and study that we did with MALDI-TOF when we first brought that online, now probably about a decade ago, that if using MALDI-TOF for rapid identification and setting up rapid susceptibilities direct from blood cultures, that we could basically reduce turnaround time significantly and show benefit for length of stay and morbidity and mortality in our patients. And so we felt like that a variety of things with the Kiestra would also generate similar benefits. One would be a decrease in restreaking. It's been published by others, not by us, that using these automation systems like the Kiestra, you get better colony isolation on the plates, you get more consistent streaking pattern, you have a lower incidence of restreaking, and that certainly has been the case we've observed in our pre and post go live data. And then we also thought that having an automated system might help us reduce errors, increase patient safety. And there is another benefit I'll get to here in a few slides that comes from the continuous incubation and the fact that in the automation system, the plates are living in the incubator, being imaged in the incubator. They're not getting taken out and put at room temperature for hours on end while they're being read, which actually leads cultures to turn positive faster. This is just our track record, and this helped with our buy-in with leadership in terms of what we did with MALDI and how we showed that with MALDI that faster turnaround times could benefit patients. And so the fact that we had done this previously and shown that the decrease in turnaround time could benefit patient care directly actually helped justify the ROI on the MALDI very quickly, helped us get a second MALDI, and gave us some political capital of leadership that these ideas in practice, we could put them into practice and show the benefits that we were suggesting. And this is just a figure from that paper looking at the timed identification. And so you can see this is for MALDI. On the top line, in our old system for blood cultures, going from the culture turning positive to then, growing the positive up on a plate and doing identification, susceptibility, and adjusting therapy could take anywhere from 75 to anywhere from around 75 hours plus or minus some extra time there. And then after we introduced the MALDI and we started doing essentially spinning down the pellets from a positive blood culture, placing it directly in the MALDI and inoculating susceptibility from that, and validated that we could essentially reduce turnaround time by close to 48 hours in terms of from having the culture drawn to when the patient's antimicrobial therapy could be adjusted. There's a very important stewardship piece to that as well. But that was sort of the background we used to justify the benefits from automation. And so this reiterates these points essentially. The last point, which was really the key point, I just kind of slipped in there, but faster turnaround time is good, but it has to be acted upon, right? So if you're turning around results faster, but they're sitting in the EMR for 12 hours until the next day when someone rounds on the patient, that lacks impact at the bedside compared to having an active response to the results that you're generating. And so the way we did that with MALDI was to have active antimicrobial stewardship, and certainly having an automation line like the Kiestra feeds into such a process of if you're reducing your turnaround time from continuous incubation and things of that nature, you still need to have that robust piece on the back end that your results are getting to the patient bedside and getting acted on, whether that's antimicrobial stewardship pharmacists or some sort of system of alerts or other mechanisms for tackling it. You do have to have action to get the benefit. And so it's just important to remember that, be careful if you're promising decreased turnaround time and you don't have those mechanisms, you may have difficulty realizing the bedside impact, at least in a consistent fashion. And so I think, one thing as microbiologists we know is that traditional microbiology workflow takes time. And from accessioning to plating and then incubation, traditional micro pre-automation, we get samples in, we plate them, they go into an incubator, and then they sit in that incubator for some amount of time. And at some point, they're taken out to be read. But the reality is, while they're in the incubator, what's happening? Well, more samples are coming in, and the incubator doors are getting opened and closed. And then at the point at which the racks are taken out to be read, some of those plates have been in the incubator possibly maybe 12 or 18 hours, depending on how you've done your workflow. Some of them may have only been in there, shorter time periods. So there's a lot of variation in how long things have been incubating before they get taken out to be read in sort of traditional environments. And then if they're positive, if they're negative at first read, they go back into the incubator and get read again, maybe a day later, kind of on a fixed interval. And this cycle just sort of repeats. And again, incubator doors opening and closing. And they're only read at fixed times, and it's just sort of that's the traditional workflow, and it worked for decades, but automation offers a lot of benefits, and so this is an obligatory picture of the Kiestra system. This actually is very similar to what our system here at Methodist looks like now. We have 5 incubators instead of 6. But we do have the 2 inoculation stations on the front end and the 2 plate garages. So if you're not familiar with the system, just to orient you, is how this differs from the traditional workflow. There's essentially a range of processing options for samples. So you can have fully automated samples, like maybe urines that are in tubes, basically can be put in racks and loaded into the inocula system. And then the system will, read the barcode, see it's a urine, pull the plates out of the blue boxes there on the far left, barcode those plates, bring them over to the inoculator, put your urine sample onto the plate, drop a little bead onto the plate, streak it there in the hood and the inocula, and then take it on a bi-level track back to the incubators in the back and start imaging it on a set schedule. For some samples that are more complex, the technologists can inoculate them in the hoods there at the inocula in a more of a semi-automated mode, or a sort of full manual inoculation mode. And then what happens there at the computer monitors along the line is you have your techs, maybe on the way we do it, one side we have techs who are reading, and on the other side we have techs who are doing sort of the technical workup of those specimens. So you have your readers that are sitting there looking at plate images, so the plates are imaged in the incubators on a schedule, and then they mark colonies and things for workup or mark if the plates are negative, and then your, what we call technical assistants on the other side, are the ones setting up the MALDI, setting up the ASTs, getting in their queue colonies that have been marked for workup and calling for those plates from the incubator. So until they call for the plates for workup, the plates are just sitting happy, warm, in the incubator, growing. So it's a much better system for the pathogens on the plate in terms of getting good, consistent results and shortening that turnaround time. And it's just a continuous flow 24/7 for us. That's just a picture just to give you orientation. If you've never seen the streaking pattern with the bead, it's a little magnetic bead on the plate there in the top left. You can configure the streaking pattern within. There's a whole variety of pre-configured patterns. You can do custom patterns, and then that's just an image there at the bottom of technologists looking at plate images and working. And all the reading stations in the workup have dual monitors. Typically, there's a Kiestra. The Kiestra software is on one, and your LIS is on the second monitor, and they can work there between. I've talked a lot about continuous incubation, and so we actually wanted to test it before we got the system in. I haven't had the time or the chance to really publish this data anywhere, but I'll share it with you. I think others have published on it at this point. But I think before we went live with the Kiestra, we didn't have a full appreciation for the amount of temperature deviation that a normal auger plate went through in a traditional clinical micro workflow. And I was determined to figure out what that was and really quantify it. So I bought a USB temperature logger off of Amazon and placed the probe there on the surface of the auger plate and built this contraption to place this stack of plates in with the other plates in our workflow, and essentially took it to our technologists in accessioning and just said, here, put this with your other plates that you're accessioning, and just let it go through the workflow. And then I'll pull the data in a few days and look at it. And so what we found was that there could be up to like a 5-hour-long deviation in temperature from a time that a plate was, picked up in accessioning, put in the incubator. There on the far left, you can see it's down at our room temperature is around 22 degrees C, and that it takes these, on the x-axis, these lines are about 12 hours apart. So it takes several hours for the plates to actually get up to, towards that 38-degree mark. And then what you see in the line is there's sort of this continuous, there's a dip and then a slow recovery, then a big dip and a recovery. And so that's really, a lot of what that sawtoothing you're seeing there is the door being open and closed as more samples are added or other plates are taken out for reading and other things, causing minor perturbations in the incubator temperature. And then the big dip that you see on the far right there is when the plates were taken out for reading. And so that's where, again, some of those plates have been in there now for my tracker plate had been in there for over 24 hours. Some of the plates have maybe been in there longer, but sitting out at room temperature, it drops very quickly, really within 30 minutes. The plate drops from the incubator temperature down to room temperature and then takes quite a while to recover once it's put back. And so you wind up with these big temperature deviations in the traditional workflow. And then again, this is just this plate sat in the incubator longer, but just showing the number of sort of 2-degree perturbations in an incubator, traditional incubator, over several days. And one problem. So that got us to thinking, well, what does that actually do in terms of when plates turn positive? What's the actual impact of that? And so there was some published evidence that with continuous incubation in the Kiestra or an automation system where you have that continuous incubation, that plates could turn positive anywhere from 7 to 16 hours earlier than traditional workflows. And so we did a pilot experiment with Club Pneumo and Staph aureus to see if a 3-hour removal from the incubator impaired the time to positive culture detection. And so again, got a little creative, put a GoPro in an incubator over in a research lab, and plated out a couple of fixed concentrations of organism onto some blood auger plates, put it in the incubator with a GoPro and a light source, and set it up to incubate. Set up the camera, the GoPro, to take an image, every minute or so we could really start to see at different times, when they started turning positive. And it doesn't project very well, but essentially, if you look at sort of the on the left side where our continuous plates, and you can see some growth at the 6 o'clock position of the upper plate, and a little bit of hemolysis on the 12 o'clock position of the lower plate, which are the staph plates. Essentially, the continuous incubation, we could start to see detectable growth at this particular concentration of organism I used. I could start to see colonies that I could actually pick by about 8 hours, whereas the ones that I took out essentially in the middle of the incubation, set them out on the bench top for 3 hours at room temperature, back in, their colonies are just still not detectable. And in fact, when we looked they started being detectable about 3 hours later. So the amount of deviation to room temperature is really almost exactly correlates to the how much longer, how much faster uh, your place will turn positive with continuous incubation. And that's led us to actually change some of our read times for urine cultures and other culture types. We can actually now read the cultures earlier because of the continuous incubation, validated that, and then validated things like being able to do the antimicrobial susceptibilities at earlier time points. So um, the continuous incubation really is one of the sort of killer features of an automation line that will let you get positive results faster and could really help, theoretically then help you get results at bedside faster and get benefits to patients in that way. So this was the first sample type we went live with was urines, and so this was our looking at our time from plating to identification uh, for our urine cultures, and the red line is pre-Kiestra and the blue line is post-Kiestra, and they're on the bottom about hours. Um, And so what you can tell is that, previously we were reading on a set schedule pre-Kiestra, so we had a reading that was, generally fell around a day later, and then a second read that would be at, basically day two, and then they would go out. And with the Kiestra, we instituted more of a 12-hour read, and then a read at 36 hours. And so um, and the techs can always hold, they can always add an additional incubation if they think, there's something growing, but they can't quite see the colonies yet. They can always add more. Which may be some of what you see in that little third hump on the post Kiestra. But basically, that's looking at this graph, you can see that it shifted our time to identification of positive urines, pretty substantially to the left. I wish, and I would show that a different way here. Go to the next slide, and this is just our percentile of urine cultures resulted from plating to identification. And so you can see again, the red is pre-Kiestra, the blue is post-Kiestra. So pre-Kiestra, we were getting around half of our, it's interesting because the halfway point is about the same, but then if you look at the actual individual cultures, the blue line is shifted over to the left, so you're getting earlier identification, and then you're hitting that, you're getting a lot of them identified sooner, is what I'm trying to say. And does it actually benefit patients? That is something we've looked at. It's kind of interesting. So we looked at it in the ICU, our ICU patients, and we saw for the first 3 months or so after go live with our patients with urine cultures, we saw a decreased length of stay. But we were a little skeptical that urine cultures in ICU patients can be that important, and so we kept watching, and it was an artifact. It was something else going on in the ICU at that time. We wanted to get in. We went live with urines first. Within the first year after go live, we went live with all of our specimen types that we're going to put on the Kiestra. And I have since wanted to go back and look at other specimen types. Unfortunately, there was this whole global pandemic that happened, and that's just sort of turned my schedule upside down and certainly altered the course of everything in our ICUs. And so we're sort of have been waiting for the COVID to calm down enough that we have the time to look at that data and then try to get our ICUs back to more of a pre-COVID state, so we have a decent comparison of data in terms of patient cultures and length of stay and morbidity, mortality, those sorts of things. It's just been, everything got a little bit perturbed right around the time we started to look at that data. So just to summarize the turnaround time benefits, again, your cultures are going to turn positive faster. It's really, the continuous incubation is really cool. The ability to image the plates inside the incubator is very nice, and the fact that they can sit there in the incubator until someone calls for that plate to work it up is just really fantastic. The streaking is much more consistent, and you get better colony isolation, and so you get fewer repeats and fewer restreaks. I do know from our MALDI example, for instance, that faster turnaround times can benefit patient care. Again, we just haven't been able to pull the data to actually do the studies here yet, thanks to the pandemic, but we are working on it, and I think there's been some other people who have published in the meantime as well. And so we're still working on our data so we can share that, of course, with the community. And I will, again, for your business case, just to summarize, don't promise to reduce. I would recommend not promising a reduction in FTEs, because unless you really, really think that'll happen, unless somehow, by some miracle, you're overstaffed. Work on promising the increased efficiency and cost avoidance, even though it's a little bit of a tougher road. Patient care benefits are real, but they can be difficult to quantify. So if you're going to promise that, be ready to pull the data and make that case after go live. Um, there's an inherent skepticism in most hospital leadership around vendor-provided ROIs, so be prepared to run your own numbers and have your own estimate, because if you come in with a slick ROI from a vendor, your leadership may not buy into it. And then the other thing, and Pat may get into this too, is this general caveats about automation. A wise man, Dr. Wayne Chandler, once told me, you can't automate your way out of a bad process. So the Kiestra is going to change how your workflow in your lab works. You may have, and we learned that sort of early on in our preparation process. We thought we had questions, and we realized we were asking the wrong questions because it was going to change how we did things. But that was okay. And so you can't, if you're having issues with your workflow in your lab, or you're having, you can't just automate. You can't automate your way out of a bad process. You have to kind of fix the process or realize how, using a new tool like the Kiestra, your workflow and things are going to change, and you can fix the process through the change. But it is a big change, and so you have to be, the change management is really critical, and I think Pat is going to talk to us a lot more about that, and we'll have you answer any questions about it. I think I've exhausted my time. I'll throw up one quick acknowledgement slide to all the team here at Houston Methodist, including our fantastic technologists in the Diagnostic Micro Lab. And I will now hand it over to Pat.
Thank you very much, Wes. I will elaborate on the experience that we had in actually educating our staff about the MALDI and how we progressed on to the implementation. Basically, you need to educate your employees as soon as possible, because one of the things that you want to do is get them prepared in their mindset for what the changes are going to be. We started asking for the Kiestra about 2 years before it was approved. And at that time, we started letting the employees know what we were asking for and basically what it would do for the laboratory. We asked BD to come in and make a presentation to all of our shifts so they had some concept of what the instrumentation looked like, how it operated, and what they were in for. We actually started talking with the employees about, we didn't know what was going to happen with schedule changes, but we tried to emphasize to them that we were, as Dr. Long said, stating to the upper management that we did not intend to have a reduction of employees, but that we would use the employees in other areas. But I think you have to be upfront with the employees and tell them that we don't know if we're going to have employees coming in earlier, staying later, or because the instrument in itself can dictate those time readings of the cultures. So you need to pick a site visit. This was probably the biggest eye-opener for us during this whole event. Look at a facility that is approximate to your size in volume. And we went to North Shore in Illinois, and we had worked hours on creating a list of questions that we wanted to ask them. We took our camera with us. We were as prepared as what we could be. When we got there, we took different levels of employees along with us. We took Dr. Long and myself, some of our chief techs, a line employee, but we wanted to literally have everybody talk to compadres so that we could get an idea as to how it was going to affect those different areas of where the employees work. As soon as we got there, we realized that our questions were irrelevant because we were trying to fit a square peg into a round hole, because what questions you're asking don't necessarily fit into the workflow that the Kiestra is going to create. Well, some of the things that you can do beforehand, you need to try to do. For instance, if the rotational schedule, one of the things that we found to be, the employees always liked following themselves. If they were reading cultures today, they read at the same bench the next day and the next day for that week so that they could have a little continuity of it. Well, when we did our site visit and watching the workflow, we realized that basically that wasn't going to be happening. You can do it that way, but we wanted to realize the most efficiencies. So we actually were going to be having readers, and BD calls them workers, but we didn't want people to feel like that they weren't working if they were a reader, so we renamed them as task analysts or TAs. So you were going to have people just reading the cultures and marking for activities to be done or tasks to be done, and then those TAs would be pulling off those tasks to be performed and doing that. That was a big change. So we actually started changing the rotational schedule so that you were not reading behind yourself, preparing the employees that when you were sitting down to reading a culture that you were looking at it with fresh eyes every day. That helped them get used to, you're going to have to look at the work card and not remember what you did to something yesterday. We also changed some media and tubes before we went live on the Kiestra. We changed to the eSwab before we went live on the Kiestra. That enabled the employees to get used to collecting both aerobic and anaerobic in the same container, and basically getting used to handling it and getting the nursing staff used to collecting those types of specimens. You're going to do a lot of work with IT. You're going to be seeing them a whole lot more than you ever did, so make sure you're on good terms with them. On the changes, you're going to be using folders for the types of cultures. And if you're in a laboratory that you read cultures by source, like you have a urine bench or you have a sterile body fluid bench or a stool bench, that's not going to be much different than it is. But if you read cultures by patient name, which is what we did, it's going to be a big difference. We always read by culture name to keep the patient work consistent. So if you had one organism growing in multiple cultures on that same patient, you had the opportunity to keep them together. So this was a big change for us, but you're going to have to address that with the staff also. You do not want to go and change everything at one time. This is a big change for the employees. And one of the things that we did is we started with what we thought would be the simplest culture type, which would be urines. Every one of our technical staff in our laboratory on all three shifts basically knew how to read urine cultures. So one that would involve every person on every shift to start off with. So we weren't, just letting the day shift do it like many times things happen. It is very high volume, and it's we get tons of them. We established our validation plan, how many cultures we thought would not just show the work would be the same as cultures read by hand or better than the cultures read by hand, but you had to prove it to the employees, and you would have to do some to let them practice with. We took images at multiple times, at 8 hours, at 10 hours, at 12 hours, at 14 hours, to basically see which images were going to give us the best isolated colonies. We involved the employees in this because they're the ones who are going to have to look at the images to do the workups. Don't reinvent the wheel. If another facility, maybe the site visit that you went to, told you that 8 hours is not enough, that they've repeatedly looked at it, take their word for it. Go on to another, like the 10-hour or the 12-hour. We developed reference pictures for the employees and laminated them and put them next to the workstation so the employees had something to look at, so they could say, oh yes, that this is the colony type or the colony count. We went from a pour plate method for urines to essentially the calibrated loop method, and so it was a change for us, and so that's one of the reasons why we did the pictures. You want to make sure and train your main users first. Because you're going to be doing urines and so many of them, you want to train your medical laboratory assistants first and the people who are going to be the trainers. I think a lot of laboratories always utilize the same employees to train new employees, and that helped us tremendously by starting off with those people. But you have to let the employees practice and practice and practice. I can't emphasize enough that the employees have to gain confidence in this system before that they will make sure that it works. And by them gaining confidence, they'll be able to read and mark with authority and then move on to the other ones. We actually gave each employee 10 cultures that they had to work on in the same type of work scenario that they would. They could look at as many images as they possibly wanted. We had all of our validation cultures on the system that they could look at the images and basically put the work in the work card, and we would examine their work cards and make sure that everything was done appropriately. Pick some staff that you know are good troubleshooters and train them on the actual troubleshooting on the instrument. We actually chose that every employee has to sign on to the Kiestra with an ID so we know who's doing what, and that has been a tremendous help because we can actually see that employees are not troubleshooting or are troubleshooting, or when they're opening and closing cultures. That really helps us pinpoint problems. Everybody needs to be able to call BD and work through a resolution with them. Our staff over the years have gotten so comfortable with calling BD, from our medical laboratory assistants to our chief techs. Every one of them is comfortable in calling BD at any hour of the day and getting help from them. They routinely, we have a group email for the whole staff. When they get through calling, they send an email out to the team saying, we've called, this is the problem, this is the case number, you should be expecting a call from wherever. And it really does work well. Your specimen issues, you do have to work with nursing education to establish requirements for the urine collection tubes. I wish we would have worked a little harder on that. We did get the new collection kits in so that they were always in the gray top tube, but we didn't mandate it. And I wish we would have, because it would have helped us not to transfer specimens into gray top tubes to put them on the system. But you have to make a decision. If it's not going to come in a gray top tube, what are you going to do to it? Are you going to do it semi-automated or automated? But those are things that you have to decide before you're going to start your system. Urine culture reading can be a big change for you depending on what method you're currently using. It is a quantitative method, as all urine cultures are, but the method is very different. At least for us it was, and even if you're using a calibrated loop, it's still different than a classic calibrated loop. So you do have to get people used to that change. Have pictures so your staff can look at them. And again, I can't emphasize enough how you need to have your staff practice and practice. This is an example of an E. coli at a colony count of 10 to the 4th. And this is directly taken from the instrument in itself. A couple of things about the culture workup that you have to understand in order to be able to troubleshoot problems with culture interpretation. You're going to have many more hands on one culture, and it can be very confusing. So you have the person who does the first read, marks it for workup. Somebody else is going to be doing the identification. Somebody else may be doing the susceptibility. And then somebody else is coming back and putting the results in or doing a second read. So it is basically a lot of fingers in the pie. You have to make sure everybody documents all of their work. One of the biggest problems we have faced is that you mark stuff in the Kiestra, but you document and you bill out of our LIS, and that has been confusing for staff. And it's one thing we really emphasize when we are training. The employees got together and actually made sure that all of the duties of the reader versus the task analyst were defined. And I can tell you that we've redefined them several times because we have fine-tuned things over the years. But we get the employees together about every 6 months, review it, and then review those new duties with all of the employees. Everybody is held accountable for their responsibilities. One of the things you may want to re-examine is spot testing. If you are going to do spot testing, is the reader going to do it, or is the task analyst going to do it? We tried eliminating the spot testing like endos for E. coli and that, but it kind of overwhelmed the person with the Maldives, and actually we found that it was delaying identifications. So we re-implemented the spot testing, and we saw a decrease in the turnaround time on the identifications. Sometimes it's trial and error. Remember that every time you pull the plates out of the incubator, you are cutting into the incubation time. So you really have to work with the staff on practicing with the images. Put any kind of organism you can think of on the plates, put them in the incubator, and let them view what the colonies look like. And you do need to remember to let the employees have a voice in defining the workflow. They know it better than you do as a manager or as a pathologist, and they will accept the changes much better if you actually let them participate in it. When you are getting ready to go live, we have to make sure that everyone gets a chance to be the reader or the task analyst or the inocula before the system goes live with that type of culture. We made sure everybody could do the urines on all areas, got that down. Well, we probably had urines going for about 3 to 4 months before we started on the second type of cultures, which were sterile body fluids. And that worked to our advantage because everybody felt pretty comfortable with it because we made sure that everybody got to be a reader and a task analyst. The employees made suggestions on workflow changes constantly. We had to kind of say we've got to have a way for everybody to turn in suggestions for the workflow changes, for us to evaluate them, and then get back to the employees as to why it worked or why it didn't work. Again, you have to work with your nursing education about the collection containers for each set of cultures that you are ready to bring on. When you're going to bring the next set of cultures on, are the employees that are going to be doing it? Are they learning a new skill? All of our employees knew how, all of our MLTs and MLSs knew how to read urine cultures, but the evening and night shift did not know how to read sterile body fluids or respiratories or anything else. So when we started on the next set of cultures, i.e. sterile body fluids, we made sure that we started with these sterile body fluids because they would have some positive, but not a tremendous number of positives, and it would ease them in to be able to looking at cultures with broths and examining the cultures on multiple days. The positive blood cultures were included in this, and I was really pleased with how this went with the employees that did not have skills in reading the other cultures. It was more of a gradual approach to it, and they did quite well. It took us about 3 to 4 months again to get all of them trained and on reading the cultures and then implementing the sterile body fluids. Validate your cultures again with specific reading times. train the employees and let them practice, practice, and practice. I can't emphasize enough how important letting the employees have time on the instrument and so that they can train their eyes. Make sure everyone gets practice on, again, the reading and the TA part. And again, we redefine the duties of the TAs. Every time we put on a new culture type, those duties and that sometimes changed. Once it's live, again, make sure that before you're thinking about your third set, as we did, you could do 2 go lives or 4 go lives, but make sure everybody gets a chance to be the reader and the TA and the inocula tech before you go on to your next one. You think you thought of everything, you just knew it, but then reality hits. And usually you've thought of all the major issues, but it's the little things that you don't think about. And those are the ones that the employees will come up with. Well, we didn't decide where this racks were going to go in the incubator. It's confusing which shift is doing them. So it's those types of things that we had to address later. In the last go live, we just repeated the steps from previous ones. We started off with the respiratory cultures having images taken at a longer time, essentially 24 hours, and we have not changed that. That seems to work really well for us on those respiratory cultures. We don't have to send out a report that says it's too young, we're going to read it later. We usually have something very visible to grow with 24 hours. And you also have to consider those cultures that are not going to go on the Kiestra. Are you going to inoculate them on the Kiestra in the semi-automated mode, or are you going to inoculate them manually? For instance, like your anaerobic cultures, if you have any other plated cultures, IV catheter tips or something like that. Some of the lessons that we learned were essentially, one of the most challenging areas was the inocula specimens that had AFB and fungus cultures and aerobic and anaerobic cultures. We found we couldn't split those specimens. You actually had to take those specimens like bronchial washings and do everything in a manual mode. It got too confusing for the employees. We did find that inoculation of cultures that don't incubate on the Kiestra works extremely well. They just go to a bin, we pick them up, put them in the anaerobe bins. Great. Utilize it as much as you can. There are problems in keeping the work on the LIS, the recording results on the LIS, and the marking on the Kiestra. Make sure that you outline what goes on each. The workflow documentation, you just have to keep on people. Planning ahead is absolutely essential, and anything that you can do beforehand, making changes, rotational, reading cultures, containers, that all will help. One of the things that we did not anticipate that the employees told us about was that the employees felt differently about reading the cultures. They felt that in the old way, when you were handling the cultures themselves, that they had a feeling of accomplishment when they went home. They did a day's work. They left feeling good, I got it all done. When they leave now, they don't have quite that same feeling because they may have just read the cultures. And there's still some that have to be read because it's so continuous. And it's a little bit different in a mentality. So that did affect the employees in that way. Making sure everybody knows how to troubleshoot it. That is a requirement here. You have to troubleshoot it yourself. Be sure and listen to the employees. They've come up with absolutely fantastic ideas. And it is stressful. So we celebrated a lot. When we had, when the urines went through and we were at the end of that, right before we went to the next culture type, we did celebrate. You have to make sure that you do. And yes, we would do it again. So that's my presentation. Thank you very much for your attendance. And I think that now that we'll be entertaining questions.
Thank you, Dr. Long and Ms. Chernock, for your informative presentation. We will now start the live Q&A portion of the webinar. If you have a question you'd like to ask, please do so now. Just click on the Ask a Question box located on the far left of your screen. We'll answer as many of your questions as we have time for. Let's get started. Our first question is, how has the Kiestra system helped your lab during COVID?
I wanted to, I saw this question at first and I thought, well, I mean, really, it didn't run COVID tests, so it wasn't that helpful. But actually, one of the things that I would say was helpful was, since it changed our workflow and we went to a situation, before we had the Kiestra, there were certain shifts, in the middle of the night where plates maybe weren't being read. And not all technologists were reading plates. There was cross-training, but there wasn't the same sort of cross-training as once we moved to the Kiestra and we moved to the automation system, and plates were being coming ready to be read 24/7. We had to train more of our techs in reading plates and doing other things. And so I think because of that, at least in my perception, during COVID, when we went through peaks where we had multiple technologists who were out, unfortunately, either with COVID or with family members with COVID, et cetera, I think it made us a little bit more flexible in terms of our labor and how we could have other techs pick up the slack to do plate reading and other things. So I think in that case, the way it changed our workflow and our cross training helped.
Great, thank you. Our next question, is it possible to have incubators at different atmospheres, e.g. ambient versus 5% CO2?
Yes, we do have 2 CO2 incubators and 3 ambient air incubators on the Kiestra.
All right. Next question. How did the incubation decrease impact your staffing models, assuming MALDI-TOF changed it in the first place, and this would have changed it again?
We actually didn't change our staffing models for the culture reading. We did try some employees coming in earlier for a while and some staying later, but we found that it didn't help. It really actually hurt more so than it helped. We kept our regular 3 shifts. When we actually were able to get some new positions because of increased workload, we moved them to the shifts that had the heaviest reader time, and that helped us even it out a little.
All right. Next question. How do you deal with CLSI's organism age requirements for susceptibility testing?
We did a validation on how old the colonies were. If they were, a lot of times your colonies are about 12 hours old when you pick them. And we did susceptibility testing at that time that we picked them, which is usually, even though it's 12 hours when you read them, by the time you pick them, it may be 12 hours. And then at the routine time of about 24 hours, and we did not see any significant difference. For instance, there was no interpretation difference in the susceptibilities.
Great, thank you. Next question. Have you considered having techs work from home when reading plates from the computer?
Well, I marked this one. I wanted to say it's certainly something I have thought about. There's certain CAP requirements and regulations related to digital pathology, and there's been certain relaxations. I think to do it properly, you would probably have to issue technologists a standard. The monitor on the Kiestra is a fairly high definition monitor. I think you would have to replicate that at home to have some consistency. But it is, we live in Houston. We have hurricanes and freezes and other things where it makes it difficult for people to come into work. And it is in some ways attractive to me as a medical director to think about possibilities of, is there a way we could have people read plates from home? And I think that future may be coming, but I do think there's just some logistics to be worked out in terms of, standardization of monitors and how to operationalize it in terms of, paying for the employees and how that, how would you pay the employees that are off site and how would you, track the work? But I do think it's a tantalizing possibility with the system that may be on the horizon. I don't know how far it is out there.
Can tell you that I have the system on my computer in the office, and they'll mark it for a manager review, and it's so nice to be able to just to view it here and not have to go into the laboratory, and I can make comments on it, and it works out great in that respect.
Okay, great. Thank you. Next question. Did you look at the Copan WASP Lab 2? What were the benefits that led you to go with the BD Kiestra?
I would say just off the top, my recollection is when we looked at it in our initial, for our volumes and our throughput, once they did the final, we did discuss with both vendors, and that the Copan, the WASP system came back, and we were going to need 2 separate WASP lines. And by the time we were going to have enough, I guess the equivalent WASP system was really going to be not that much less expensive than the Kiestra, and for that reason, that was one of the major drivers for me. And then also we're also, full disclosure, a fairly BD heavy operation with instrumentation, and so we had that pre-existing vendor relationship, and so that made the decision a little easier too. But I think that for me, and I was associate director at the time, but that was one of the major things was once we finally did the final calculations, it wasn't actually all that much more cheaper than the Kiestra system that met our needs.
All right, thank you. Next question. Can you share a little information about the demographics in your lab employees?
Yes, our employees here in the laboratory, it's probably less than 60. We probably have about 80% of our employees that are less than 60, and the remaining 20% are over 60. The majority of the older employees adapted very well to it. The new employees, the new graduates, oh my gosh, they just take to it like a fish to water. The other employees in the mid-range do very well with it. They may take a little bit longer because they're not quite as used to all the features of the computer, but overall, it was very well received. We are the only ones in Houston who have the size Kiestra that we do, and I can tell you that it's been a feature that has helped us with our staffing. We have people come to work here because of the Kiestra, because we have an automation line, and we have a lot of other toys. And people, especially the younger techs, migrate to a place that has automation and a technology.
Okay. Next question. What kind of communication did you provide your clinicians as far as changes in the go lives?
We didn't.
I think we, so there were, we did a lot of pre-work in terms of switching specimen containers to the eSwab container, standardizing specimen containers long before we went live with the system. And we tried to preload as many changes as we could to sort of get those, get the swabs changed out and get any old swabs out of sort of the supply chain off the floors before we went live. And then I think in terms of, but since it didn't change anything in terms of how they were ordering cultures or, things on their end, we didn't do any specific communications about the go lives on the Kiestra because for the clinicians it was fairly seamless. We certainly, once we were live, promoted it in our departmental newsletter and things of that nature, but it didn't. We generally only notify clinicians if there's, if we're changing a test or they need to change something about how they're practicing or order something differently or new tests we bring online, those sorts of things. But I don't remember any specific notifications about our Kiestra go lives because it was, for the most part, it was fairly seamless for our clinicians.
All right. Next question. Have you been able to reduce the workload for employees even without looking to reduce total FTE counts?
I don't think our employee workload has gone down because our overall workload has pretty much increased. Pat, what do you think?
Our workload has increased so dramatically in 21 that I have gotten 6 new positions. So I don't think that question is relevant for us.
All right.
We just have too much organic growth in the system to really gauge that.
Okay. Well, it looks like we have time for one more question. How many times did you present your justification to leadership to attain it?
I would say, to me, it felt like several times. We started initial discussions. There was money allocated for sort of some architectural studies and analysis and feasibility studies and looking at, as part of a larger move of our lab from one building to another with automation in mind. And then there was, we sort of went forward at one point and then stopped for some more financial reviews coming out of leadership and provided more justification. And then after that period, it finally got approved. And after COVID, everything pre-COVID is a little fuzzy, but there was sort of a couple of years of starts and stops and multiple justifications we went through before we finally got the full ticket price approved.
It was on the 3rd year, like Dr. Long says, and for such a huge expenditure for us, that's about how long it usually takes us.
Well, thank you again, Dr. Long and Ms. Chernock, for your time today and your important research. We would also like to thank Labroots and our sponsor, BD, for underwriting today's educational webcast. Before we go, I'd like to thank the audience for joining us today and for their interesting questions. Questions we did not have time for today, and those submitted during the on-demand period, will be addressed by the speaker via the contact information you provided at the time of registration. This webcast can be viewed on demand. Labroots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. Until next time, goodbye.